Hey there, everybody. Welcome back. This will be the last video for 13.6. We're looking at directional derivatives and how they relate to contour lines. In general, gradients are normal vectors to level curves and contours. The gradient points towards the higher regions, as we saw in the previous sections. When u is in the direction of the gradient of the function, that's our steepest ascent, and it's the magnitude of f squared when we do the gradient of f dotted with u for our directional, our slope. And when we do u is the opposite of the gradient of f, it's the steepest ascent, and we have the magnitude is the negative square of negative square of the magnitude. So what else is going on here? In fact, we had the max pointed is positive, and then in the steepest ascent, it's negative. In fact, anytime that gradient f dotted with u is not zero, there's some slope. We either have some uphill ascent, which is ascent, or we're going downhill. Remember, contour lines means lines of the same height, which means there's no slope. You're not going up. The rise is zero. So we want the slope to be zero. And that's what we get when we do the gradient of f dotted with u. So we do the gradient of f dotted with u, we've got no slope, which means u is pointing in the direction of a level curve. And another name for level curve is contour lines. They say level curve because everything along that curve is the same level. We do the gradient of f dot with u. We know that u is the tangent vector at that point to that contour line. Well, we know u is a unit vector that's tangent to the line, but when we do make it equal to zero, the gradient of f dot with u is now in the tangent. There's a tangent line for that contour line. So if we had some slope, some surface thing, and we had a function for the contour lines, the tangent would be in the direction of u. That's pretty effing cool. Okay? Pretty effing cool. So let's take a look at y. For a level curve, the contour line at x naught, y naught, the contour line would be z equals f of x naught, y naught is constant. So we have t as our tangent vector. We'll do it as a function of arc length, such that the function is a constant along that line. Now we take the derivative with respect to s. So remember, do the chain rule. The right side is zero, and we have the gradient of f, or not the gradient f. We have the derivative of f with respect to x times the derivative of x with respect to s, plus the derivative of f with respect to y times the derivative of y with respect to s, chain rule. That is our gradient. And dx, ds, dy, ds is the tangent vector at that point. So the dot product is zero. It's showing they are orthogonal, assuming that neither of those has a magnitude of zero. Which means our gradient of f is a normal vector. Okay, the gradient of f by itself is a normal vector to the curve line, and we'll see how that plays in the next section. We do have an example with it, so let's take a look at it. Find a unit vector u that is normal at the point 2, -3 to the level curve of f of xy, where f of xy equals 3x squared y minus xy, and that curve is going through the point P. That's kind of important. So we could see that at the point 2, -3, the value has a height of -30. That's our constant. Okay. We are looking for the unit vector that is normal to the z equals -30 contour line. Since it's the same height, we're like 30 feet below sea level, effectively, if we did it on the terrain of the earth. So let's just do our derivative. We've got our partials of f with respect to x and y, blah, blah, right here. We evaluate them at those points, more blah, blah, exciting stuff, plug and chug. We get the partial of f with respect to x at that point is negative 33. The partial of f with respect to y at that point is 10. We want the gradient of f dotted with ud equals 0. We know the gradient of f is negative 33 and 10. We could normalize that by dividing by its magnitude. So we're going to call that our normal vector n. That's our gradient of f. We need to dot it with u1 and u2. We need to pick u1 and u2 such that the dot product is 0. It's usually just the easiest to swap the numbers and change the sign of only one of them. So that's what I did. I put the 10 in the x spot and the 33 in the y spot, and I changed the sign of 33 from negative to positive, such that when we do the dot product, we get 0. Okay. So our unit vector, our u, we want to make it a unit vector. The tangent vector is a unit vector. So is the normal vector. That's why I took it divided by the norm. So we're going to get that tangent vector, do some math, blah, blah. You get 0.29 and 0.957. And the normal vector is negative 0.957 and 0.290. So that's it for 13.6. Peace.